Prepare for trouble and make it double.
To protect the world from devastation.
To unite all peoples within our nation.
To denounce the evils of truth and love.
To extend our reach to the stars above.
Will.
Jordan.
Team Rocket blasts off at the speed of light.
Surrender now or prepare to fight.
Richie, that's right.
Hi, we are Team Rocket, and we're introducing Project AMAN, the automated movie actor nexus. To start off with Project AMAN, we used a plugin Beautiful Soup to web scrape off of imdb.com a list of movie codes. And once we took the movie codes, we used another library, IMDb Pi, to generate the cast list. We fed both of those cast lists into, we wrote a file, a CSV file to hold the movies and the actor list. And so the first columns of movies and the rest are the actors in that movie. And so then we use that CSV file to then read back in to generate our graph structure.
And then going in briefly to our graph structure, we used basically two nested maps where the first map links an actor's name as a string to an actor object. And then each actor object has a name, a list of the movies they were in, and then another map, which is basically our edge list, and it links the co-star's name to the movie that they share with the main actor. And moving back over to our main function, we have a few different implementations you can use. We have classic Dijkstra's, as well as breadth first search. And then we can also display the number of actors that an actor has been in a movie with, as well as the actual movies that this actor has been with. So we're going to start off with breadth first search, and while it's running, Jordan's going to talk about it.
All right, so our breadth first search is pretty standard, but since we want to find the path between two actors, the shortest path, of course, in the queue, we'll just push back a path between two actors, essentially. And then that way we can trace back the actual path and we could list the movies that connect the actors rather than just getting to the end vertex. And there you can see the result of it. If we input Mel Gibson and Madeline Stone, they were in one movie together. We were soldiers, and that's the only salient connection. So I'll let Richie talk about our implementation of Dijkstra's algorithm now.
Yep, so moving on to Dijkstra's, we're going to use a few edge cases here. We're going to start out with Kevin Bacon and see how many movies Kevin Bacon has been in with Kevin Bacon. As you can see, our algorithms are case insensitive, and Kevin Bacon is 0 movies apart from Kevin Bacon because he has been in quite a few movies with himself. And then another edge case, which is the longest one we could find, is Addie Jones and an actor named RZA, which will take a short bit of time, but they should have a distance of 3, which you can see that they are 3 movies apart. And then you have the movie path as well as the actor path, which shows where you start with, the in-betweens, and then where you end with. Now, going through Dijkstra's real quickly, it's a pretty standard implementation of Dijkstra's where the only difference is that each weight is 1. So you go through, you add everything to the queue, make sure that you're visiting unique vertices, and then you just find a total size. Now, moving on to the last 2 ways that we can use our algorithm, we have the number of unique actors that you can be in, that a specific actor has been in with. So we're going to start with Kevin Bacon, who has been in a movie with 1,436 other unique actors, which kind of gives credit to the law of Bacon. And then finally, just looking at the movies of Kevin Bacon we have in here, we see that he has been in 17 movies, and this is all the movies that they have been in. And then one last test is just to show that if we put an actor name that is not on the list, so let's say Will is an invalid actor name. Sorry, Will. And then now moving on to the ending.
My bad.
We also have one last command to exit the program, which will break out of the while loop that takes user input and end the program.
All right, guys. Thank you for watching our presentation, and we'll see you later.
Thank you.
See you, folks.